Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, ABHUT wa sauce, GOBELA we maths. Right. So without any further ado, let's look at this question one that we have here. We are looking at quadratic sequence mixed with some of linear sequences and also your geometric sequence. Right. Also, your linear sequence is what we know as the arithmetic sequence in grade 12. Right. So note again that what the questions that we are using here are from past exam papers, so that when you practice, everything is in the same level of what you should expect in your exam, right? So we do not play here. We are trying to be prepared for the exams that are ahead. So you'll be writing your March exam very soon. And then after then, that's your June exam and your prelims soon after. Then before you can even know it, you'll be writing your final exams, right? So because I'm saying this in December, it can sound a little bit funny, but then just few nights and days, you'll just be writing your exam and you don't want to find yourself panicking, right? So it is always very important to start early, right? So let's just get right down to the question without wasting any further time. So we have consider the quadratic sequence. We are given 2, 7, 14, and then 23. Then our first question here, 1.1, says write down the fifth term. So we know this about a quadratic sequence, that a quadratic sequence has the first difference and the second difference. The first difference of the quadratic sequence is always what we know as the arithmetic sequence. So we just find this by subtracting here 7 minus 2, that's 5. And then if we say 14 minus 7, that's 7, and then 23 minus 14, that's 9. Right, so our second difference would be 7 minus 5, that's 2, and then 9 minus 7, that's 2. So as we can see here, we have a consistent second difference. Right, now to write the fifth term, all you have to do is put in 2 there because it's consistent, and then the 9 plus 2 will give us 11. Now what must we do? We must add this 11 here with the 23, then 23 plus 11, that's going to give us 34. So just like that, you have found your fifth term. That means T5 is equals to 34. Right, now 1.2 says determine the general term Tn. So what are we supposed to do here? We know that we equate the second difference to 2a, then equate the first difference to 3a plus b, then the term of the quadratic sequence to a plus b plus c. Then we know for that we have to select the first branch like that. So there we go. Now let's calculate this. We have 2a is equals to 2. Then if we divide both sides by 2, our a is equals to 1. Right, then now we want to find the value of b, so we can say 3, and then in bracket we have 1 plus b is equals to 5. So this is b is equals to 5 minus 3, then our b is equals to 2. To find the value of c, it's a plus b plus c. So our a value, let's just substitute. We have our a value is 1, and then our b value is 2, then plus c is equals to 2. So 1 plus 2 meant to say is 3, and then 2 minus 3, that c is equals to -1. So writing our Tn, that will be Tn is equals to, remember we are writing it in this form, an squared plus bn plus c, right? So that means our Tn is equals to, our a is 1, so that's just n squared, and then our b is 2, so plus 2n, then our c is -1, so -1. So we have our general term now, that's n squared plus 2n minus 1. That's how you were expected to solve this, right? Then let's get to the third question here. 1.3 says if 5 is added to each term of the quadratic sequence, between which two terms of the sequence is the first difference 57. Now note this, if we are adding 5 to each term here, this will not change This will not change our first difference. So let's see that. Remember, they're saying we are adding 5 to each term. So that means that's 2 plus 5. The first term now will be 7. And then if we say 7 plus 5, the second term will be 12. And then if we say 14 plus 5, the third term will be 19. Then the fourth term, 23 plus 5, that will be 28, right? So I want you to observe something here. If we say 12 minus 7, right? So 12 minus 7 still gives us what? 5, right? And then if we say 19 minus 12, this still gives us 7. And then if you say 28 minus 9, this still gives us 9. So this in a way does not change your first difference, right? So you see this type of questions, this is where they just play tricks with your mind, right? So that they know that you'll be panicking and be asking yourself, yo, what is this 5 doing there? But then this does not really change the first difference that you found, which means it does not even change the second difference. So you still have this. Now, what are they saying? If 5 is added to each term of the quadratic sequence, between which two terms of the sequence is the first difference? Is the what? The first difference. Now, remember, we mentioned that every time we see the word first difference, we know that this relates to the arithmetic sequence. So you can see that that trend is always there, right? At this point, if you've been watching my videos and you heard me explain, now you know that that's a question you should expect. They will say something on the first difference, which you have to know that you have to relate it to the arithmetic sequence. That means we are not even concerned about what they did here, right? So you can see that that statement, the 5 is added to each term, does not even hold any value in this question here, because what we are focused on is this part, the arithmetic sequence, right? So now we must find the Tn for the arithmetic sequence. So we'll say Tn is equals to a plus n minus 1d, right? Now they're saying between which two terms of the sequence is the first difference 57. Now that means 57 is my Tn, but this is Tn for the arithmetic sequence, note. So I can just substitute 57 here. Then what's my A? The A here is the first term of the first difference, right? So that's 5. We have 5 here, and then plus n, I'm looking for that term. Remember, they said between which two terms, n minus 1. And then here, this is d, that's 2. That's the common difference. Now I have 57, so I can say 57 minus 5, take that 5 over to the side, then that's 2n minus 2. So if I say 57 minus 5, that's equals to 52. So 52. Then I can take the negative 2 over to the side. 52 plus 2 is equals to 2n. That's 54 is equals to 2n. If I divide both sides by 2 here, then what is my n value? So 54 divided by 2, that's equals to 27. But note this, right? The first difference, they're saying between which two terms of the sequence, which sequence, the quadratic sequence, is the first difference 57. Now note this, I explained this before, if you've been watching my videos. I said if we are to locate the first term of the first difference, it will be located in the first and the second term of the quadratic sequence. And then again, if I were to locate the second term of the second difference or of the first difference, that would be located in the second and the third term of the quadratic sequence. If I locate the third term of the arithmetic sequence or the first differences, that would be located between the third and the fourth term, which means this term here, term number 27 of the arithmetic sequence or of the first differences, is actually located between the 27th and the 28th term of the quadratic sequence, right? So it's located between the 27th and the 28th term of the quadratic sequence, because it is found in position number 27. So meaning it's in between 27 and 28 of the quadratic. I hope that makes sense. Then let's proceed to another question. Okay, so we have this question 3 here. It says, consider the quadratic number pattern, -145, -122, and then -101. So write down the value of T4. We can see that this is always the first question. So -145, and then -122, and then -101. So if you're wondering why I took these questions, you can even check on your maths app, right? So these questions are there. And then, but then I took them from question papers, but then I believe these questions are there because they're from past exam papers. Then -122 plus, so remember, I'm trying to find the difference from this one. So I can say -122 minus -145, right? In order to find the first term of the first difference. Then that's, that will give us 23. So we have 23 here. And then this, if we say -101 minus -122, this gives us 21, right? So we have 21 here. Now from this, we can see that our second difference is -2 because 23 minus 2, that's 21. But then remember, we are looking for T4. So we can say we have a second difference that is consistent. So that's 21. -2, that will give us 19. Now, what are we supposed to do with this 19? We must add it to this -101. So if we say -101 plus 19, that will give us the value of term number 4. So that's -84. Now, therefore, we have T4 is equals to -84. Right. Then 3.2 says, show that the general term of this number pattern is Tn is equals to -n squared plus 26n minus 178. So this one is a fairly simple question because they already gave you what it should look like. So the only thing that you are doing here is just proving that it would be like this. Now we know that the second difference should be equated to 2a, the first difference equated to 3a plus b, and then the term of the quadratic sequence 2a plus b plus c. Then once again, we take the first branch here. So guys, having to do these questions as frequent as possible, then you will see that all these questions are all similar, right? These questions are just similar. It's just a matter of changing numbers there and there, but then you are simply asked the same questions over and over again. Then this is a is equals to -1. Right. Then let's look for b. So in order to look for b, we can say substitute a, and then plus b is equals to 23, right? So if we say 3 times -1, that's -3. Then if we transpose it over to this side, it will be positive. So we have 23 plus 3, then b is equals to 26. So as you are solving this, you are looking at this equation here, and then you double check that you are still on the right path. So if we can see here, a is -1, we can see a is -1 as well. B is 26, and then we can see B is 26. Right, then let's calculate C. So for C, we're going to have substitute the value for A, that's -1, substitute the value for B, that's 26, and then plus C is equals to -145. Now C is equals to -145 plus 1 minus 26. So I just took all this and transposed it over to the side. Then my C value, that's -145 plus 1 minus 26. That's a -170, right? Now we can see that we are definitely correct. A is -1, B is 26, and then C is -170. Therefore, we can now clearly say that Tn is equals to -n squared plus 26n minus 170. Just like that, you are correct. Now 3.3. Between which two terms of the quadratic number pattern will there be a difference of -121? This is still the same question, guys. It is still the same question. Then between which two terms, let's check. Now this is asking will there be a difference of -121? Right. We still know that this difference that they're talking about is the first difference, because the difference between quadratic terms is represented by the first difference. So that means, what are we going to do there? Remember, we had 23, and then we had 21, and then we had 19 as the terms of the first difference, right? These were the terms of the first difference, which we know is the arithmetic. Then we had -2 and then -2. So that means at this point, what are we looking for? The Tn for the arithmetic pattern. So we're just going to go ahead and say Tn is equals to A plus n minus 1 and then D, right? So what's our Tn? They said -121. So we have -121 is equals to, the A value now is 23. So we have 23 plus n minus 1, and then D is -2. Now at this point, what we can do is take the 23 over to the side. That's -121 minus 23 is equals to -2n plus 2, right? Then -121 minus 23, that is -144, right? Take this 2 over to the side. -2 is equals to -2n. Then this is -146, and then is equals to -2n. If we divide both sides by 2, so let's do it here. -146 is equals to -2n. If we divide both sides by 2, then my n value is equals to -146 divided by -2. That's 73, right? But then they're saying between which two terms of the quadratic number pattern will the difference be -121? If we got n is equal to 73 for the position of the first difference, that means in respect to the quadratic number pattern, it's in between the 73rd term and the 74th term. Right. So these are the two terms where we find a difference of -121, the 73rd and the 74th term. So I hope that makes sense. Okay, question 3.4 says, what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? Now, if you read that statement like that, it is very much possible that you didn't grab anything, right? So now let's go ahead and break down the question. It says, what value must be added to each term? What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be +1, right? So now understand this. We are trying to form a new number pattern from the old or the original number pattern. But this new number pattern must have a maximum value of +1. Now, we don't know what this new number pattern is, but we know the old number pattern or the original given number pattern. So that means we can work with this one. Let's work with something that we can see, right? So I want you to understand this. The approach for this question needs you to understand something, right? It needs you to understand the relationship between the quadratic number pattern and the parabola function, right? So why am I relating the two? Because we can see that they're both expressed in terms of the quadratic format, right? So whenever you say a quadratic number pattern, just know that you are still dealing with the parabola function in a way, right? If you wanted to calculate either the maximum value or the minimum value of the quadratic number pattern, what you do, not the quadratic number pattern, the parabola function, what you do is you take this and you say x coordinate of the turning point. You use the formula here. You find the x coordinate of the turning point. Then from finding the x coordinate of the turning point, you substitute it back into the equation here of f of x. Then you find the y coordinate of the turning point, which will represent either the maximum or the minimum value, right? So y minimum or maximum value, remember, if a is greater than 0, we have a concave up graph, right? Now, a concave up graph produces a what? A minimum value, right? This one is a minimum value. But then a concave down graph, whereby a is less than 0, So a concave down graph is the one that will give us a maximum value. So why are they asking us about the maximum term here? It's because look at this, our A is negative. So that means if we had to draw a graph for this particular quadratic number pattern, then it will exactly look like this, right? Whereby this term here will be representing the term number, or whereby we will have our maximum value. So we must find the term number here. Then from finding the term number, we can be able to find the maximum value. So we're just going to go ahead with the same approach as we would if we were trying to calculate the coordinates of the turning point for the parabola function. So let's go. We have n is equal to negative b over 2a. What is our b? So we have negative and then 26, so that's b, and then 2, then what's our a? That's negative 1. Now, if we punch this in a calculator, this gives us 13. But then the 13 here, note, it is not the maximum value of the pattern. It is just the position where the maximum value occurs, right? So now we must find the maximum value of that number pattern, right? So we know that the maximum value occurs in position number 13. So we can say T 13, and then we just substitute 13 where we see n, right? Then plus 26, and then we have 13, and then minus 178. Now, if you punch all this in our calculator, our T13 is giving us negative 1. Right. So we have negative 1, which is the maximum value for this number pattern, right? This number pattern that we are given. But what about the new number pattern? Remember, we are looking for a maximum value. We want the maximum value to be positive 1. So what we have here, the maximum value is negative 1. So we have negative 1, 0, and then positive 1. We are trying to move from here to here. So how many units do we need to move from negative 1 to positive 1? That's 1, 2. So just like that, we've found our solution. That means in conclusion, we can say that therefore we need to add 2, right? So what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? We need to add 2. Right. So if we are to form a new number pattern, which will have a maximum value of positive 1, that means we need to add 2 to each term in this old number pattern. So I hope that makes sense, guys. So note the relationship that we used here, the relationship to say the quadratic number pattern is works quite the same way as the parabola function, right? So note that. Now, let's proceed to another question. We have question 2. It says, consider the following quadratic sequence. We are given 319, 280, 243, 208, 175, and 144. Now, again, to be expected, they say, show that the n term of the sequence Tn is equal to n squared minus 42n plus 360. So we already know what we must do. We have this. So let's write it, 208. I do not even need to write all of them. Then if we subtract this one, so that's 280 minus 319. It will give me negative 39. And then if I say 243 minus 280, that gives me negative 37. And then if I say 208 minus 243, that gives me negative 35, right? Then from this, we can see that our second difference will just be positive 2. So negative 37 minus negative 39, that's positive 2, minus 35, negative 35 minus negative 37, that's positive 2, right? Now, at this point, let's calculate our Tn. We know that we equate the second difference to 2a, equate the first difference to 3a plus b, then equate the term of the quadratic sequence to a plus b plus c. Now, let's calculate. We have 2a is equals to 2. then we have to divide both sides by 2, right? So our a is 1. Then we can substitute the value of a here. That's 3 times 1 plus b is equals to negative 39. Then our b is negative 39 minus 3. That's b is equals to negative 42. So as you are solving, you are looking at this expression here or equation, and then you can see that your a is 1 and then your b, yes, it's negative 42. So that means you are still on the right path. Then that's a plus b plus c is equals to 319. So what is our value for a? That's 1. And then we have b, it's negative 42, then plus c is equals to 319. Then to find our value for c, that's 319 minus 1 plus 42. Then that's 360. So that means our Tn is n squared. Therefore, Tn is n squared minus 42n plus 360. So we are correct. Now, 2.1.2 2.1.2 says determine which terms has a value of 0. Which terms, right? So this means the values for n. So we can just take this. That's only 3 marks, n squared minus 42n plus 360, then just equate it to 0. So that means we can find that it's more than one term that is equal to 0. So let's calculate. If we are to factorize this, we can use the quadratic formula, because note this is in quadratic format, right? So we can just use the quadratic formula to find the factors. So I'll just use my calculator and punch all that. So at this point, you must be able to use the quadratic formula. So I'm finding my factors as n is equals to 30. So I'm just going to go ahead and write it as n minus 30. Remember, the trick here is to make them see as if you factorize that. Then we have n is equals to 12. So I'm just going to write it as n minus 12, right? So all I'm doing is just taking this over to that side like that. Then is equals to 0. Then I can write my values. So I'm trying to get a mark for factorizing here. N is equals to 30 or n is equals to 10. So there are two values for where the value, there are two terms meant to say for which the value is equals to 0. So it's when n is equals to 30 or when n is equals to 12. So we leave them like that. Then which term in the sequence will have the lowest value? Now, why are they asking about the lowest value? It's because, look at this, our a is greater than 0. And if our a is greater than 0, what shape does this form? It's a concave up graph. And the concave up graph has a what? A minimum value. Now, a minimum value, the minimum value is the lowest value for that quadratic number pattern. So you see the relationship. Now, in grade 12, you also have to note that they will try to bring in quadratic sequence whereby you have to also use the relationship between the quadratic sequence and the parabola function. Right. So we have concave up, which is the minimum value. So how do we calculate that one? Already we know we will use the formula that we use to calculate the axis of symmetry in a parabola. But right now, we're just going to say n is equals to negative b over 2a. So we are looking for n. We are looking for which term, right? So what is our b? That's a negative 42. So I have this negative here, then inside the bracket, negative 42. And that's 2 times 1. If we calculate this, that's negative, negative, it's positive. So 42 divided by 2, that's 21. So that means our lowest value will occur in term number 21. This is where we'll have the lowest value. This is where we'll find the graph going all the way down here. So at term number 21. Nice. Pretty easy, huh? (2.2), we are given 3t, 40 minus 1, and then 23 are the first three terms of an arithmetic sequence. Then they say, prove that t is equals to 5. What is this? It's an arithmetic sequence. So this is to be expected, guys, when they ask you questions on quadratic sequence, somewhere they will just pop by and ask you about the arithmetic sequence. But then this is just a question on its own. So let's solve this. We have 3t and then 4t minus 1 and then 23. Now we know one thing about the arithmetic sequence. It has a constant difference. So that's 4t minus 1 and then minus 3t. So take the second term, subtract the first term. Then for this one, we have 23, so t3 minus t2 minus 4t minus 1, right? So why am I doing this? It's because this is an expression. So if I'm subtracting an expression, I need to put it inside the brackets. Now, what is 4t minus 3t? That's t, and then we have t minus 1. Then 23 minus 4t minus 1. If we say 23, negative, negative, that's positive. So it will be 23 plus 1. So that's 24. 24 minus 40. But then we know that the difference here is constant. So we have a common difference or a constant difference. So that's t minus 1 is equals to 24 minus 40. So to solve for t or to calculate the value of t, we can just equate the two. Now, let's bring over the negative 4t. So that's t plus 4t is equals to 24 plus 1. Then this is 5t. That is 25. Divide both sides by 5. Then there we go. My t is equals to 5. And just like that, you have scored your easy 2 marks. 2.2.2 says calculate the sum of the first 50 terms of the series. Sum, guys. So Sn, we already know if we are trying to find the sum of the arithmetic sequence, that's Sn is equals to n over 2, and then bracket 2a plus n minus 1d. So you do not even have to memorize this. If you are working with your question papers, you just flip to the last page there, which is your formula sheet. You will find this equation there. Now, sum of 50, we say S50 is equals to number of terms, that's 50 over 2. Then what is A? Our A value here, remember, we just calculated t. So we can rewrite this as 3 times 5 here. That's 15. And then if we say 4 times 5 minus 1, that's 19. And then we have 23. So these are the terms that we have there. Now, our A value is 15 plus 50 here minus 1. Then what is the difference? So to find the difference, that's 19 minus 15. And then that's 4. Also 23 minus 19, that's 4. Now punch all this in your calculator to find the sum of the 50 terms. So that was the easiest 4 marks you could get. So that gives us 5,650. Just like that, we have found our solution. Okay, let's proceed. We are killing this. We are killing this. Okay, so let's look at this question 2 here. It says, consider the quadratic sequence 72, 100, 120, and then 132. Now they say determine t and the n term of the quadratic sequence. So we know for that one, we just go 72, 100, and then 120, and then 132, right? So to find the n term, let's look at the difference here. That's 100 minus 72, that's 28. And then 120 minus 100, that's 20. And then here we have 132 minus 120, that's 12, right? Now, if we are to look for the second difference, that's 20 minus 28, negative 8, and then 12 minus 20, that's also negative 8, right? So to find Tn, we know that we have to equate this one here to 2a, equate the first difference to 3a plus b, then equate the terms of the quadratic sequence to a plus b plus c. Then to find the value of a, let's just divide both sides by 2 here. So our A is equals to negative 4. To find the value for B, that's 3 times negative 4, then plus B is equals to 28. So B is 28, then plus 12, so B is equals to 40, right? So at this point, this is kind of boring because you now know it very well. So negative 4 plus 40, then plus C is equals to 72. Then C is 72 plus 4 minus 40, then 72 plus 4 minus 40 is equals to 36. Now, this is the beauty of having to do as many practice papers as possible, because it puts you at ease when it comes to tackling your exam. So you know what to expect in your exams, because the questions that we are doing here will not be far away from the questions that you'll be asked in the exam. So it puts you in a mood whereby you are relaxed and you know what to expect. So nothing is a surprise to you. Then we have negative 4n squared plus 40n plus 36, right? So this is the nth term for the quadratic sequence. Then you have your 4 marks like that. Now, let's look at this question here, 2.1.2. It says a term in the quadratic sequence, 72, 100, 120, is equal to the 12th term of the sequence of the first differences. Determine the position of this term in the quadratic sequence. Now, they're telling you that there is a particular term or value that we get from the first differences that is equal to a term value that we'll find in the quadratic sequence. Now, in order to do that, we have to first consider when they mention sequence of first differences, we know that they are talking about the arithmetic sequence. So once again, we have 72, 100, then 120, then 132. So the first difference formed a pattern 28, and then 20, and then 12. Then here we had the second difference, negative 8. Right. So now we are focused on this part here, the arithmetic sequence. So which is the first difference. We know that the second difference here will act as our common difference, right? So this becomes our common difference. Now to find the nth term for the arithmetic sequence, we're just going to go ahead and say Tn is equals to a plus n minus 1d. But then since they told us about the 12th term, we can just go ahead and calculate the value for the 12th term. So we say T12 is equals to A is 28, right? From the arithmetic sequence or from the sequence of the first differences. Then 28 plus our n is 12, so 12 minus 1, then D is negative 8. Let's calculate the value there. That's 28 plus bracket 12 minus 1, multiply all that by negative 8, right? So we find that T12 there is negative 60, right? So T12 is negative 60 from the what? From the arithmetic sequence, right? From the arithmetic sequence. Now, they're saying that this value here also appears in the quadratic sequence, because they're saying a term in the quadratic sequence is equal to the 12th term of the sequence of first differences. So this negative 60 here is also a term value for the quadratic sequence. So what must we do in order to find the position of that term there? We can just go ahead and say, remember, we already have the Tn for the quadratic sequence, negative 4n squared plus 40n plus 36. So at this point, in order to find the position of this term in the quadratic sequence, we can take negative 60, substitute it to Tn of the quadratic sequence, and then go ahead and calculate the nth value. Now let's take all this and transpose it over to the left-hand side. So that's positive 4n squared minus 40n, then that's minus 36. We still have this minus 60 here, right? Because we took all this and brought it over to the side. So that's 4n squared minus 40n. And then if we say minus 36 minus 60, all the numbers in here are divisible by 4. So let's divide throughout by 4. Let's divide throughout by 4. we have n squared minus 10n, and then 96 divided by 4, that's 24, so that's negative 24, is equals to 0. Now, to factorize this, that's n minus 12, and then n plus 2, right? So remember, if you cannot factorize, you can still use the quadratic formula. So that means our n values are n is equals to 12, or n is equals to negative 2. But then once again, our n must be an element of natural numbers. So negative 2 is not a natural number, so we cancel it out. So that means the value negative 60 is found in the 12th position, right? So that means in the 12th position. Now let's proceed. 2.1.3 says determine the maximum value of the quadratic sequence. Again, they're saying the maximum value. Now let's understand why they said the maximum value. Looking at our general formula for the quadratic sequence, we have negative 4n squared plus 40n plus 36. Now look at this. Our a is less than 0, which tells us that we have a shape like this, a concave down shape. A concave down shape has a what? A maximum value, which is why they're saying determine the maximum value of the quadratic sequence. Now we know the maximum value is the same as the turning point, right? So in order to do that, we need the formula that goes n is equals to negative b over 2a, the one that you use to calculate the turning points of the parabola function, right? The negative b there is 40, and then we have over 2 times a. Our a is negative 4, right? So let's calculate that one. We have negative 40, and then down here, that's 2 times negative 8. So 2 times negative 4, meant to say, then that's 5, right? So our n is 5. Note that n is equals to 5 doesn't mean that n is our maximum value, but this is where the maximum value occurs. This is the position where our maximum value occurs. So we still need to get the maximum value by doing what? Taking this 5 here, substitute it back into the original equation, or the general formula equation. So that's T5 is equals to, where I see n, substitute 5. So 40 times 5, then plus 36. Then if we do this, let's find our maximum value then. Plus 36. So that's 136. So our T5 is 136. That's the maximum value of the quadratic sequence. Right. Now let's go to T4. 2.1.4. Determine the maximum value of the sequence. We are given negative 23, 5, 25, 37. But what's really funny about this question is that it's only 1 mark. So obviously, if you wanted to find the Tn for this, and then the general formula for all this, and then you use the equation negative n is equals to negative b over 2a, then from there you find the maximum value. That would be really, really absurd for just 1 mark. So that means there's something that they need you to see here. This is only just a mark. So our best shot is to look at the relationship of the numbers, right? So we have the quadratic number pattern, the old quadratic number pattern versus the new quadratic number pattern. Now we want to understand how many units was this shifted so that it creates the new pattern. So looking at 72 to negative 23, 100 to 5, we want to find out how many units was this shifted so that we find the new pattern. This one, it's pretty much easier to see. If we say 100 to 5, we can see that they shifted this 95 units downward. So why am I saying 95 units downward? Remember, we said that a quadratic number pattern behaves like this. So all the values that we get are here. And then if this has to move, let's say, for example, this part here, we have 100. So the value in here is 100. If we have to shift it to 5, that means we are shifting it downward to 5 here. So the value here would be 5. Now you understand that. So which is why I'm saying all these terms here, we shifted 95 units downward. Right. Then, so also if you can just check 72 minus 95, that's negative 23. Then 120 minus 95, that's 25. So we are just confirming that all this will be consistent with the 95 here. So every value that you see here, or every term that you see here, has been shifted downward 95 units. Okay, now that we understand that, remember in 2.1.3, we found that the maximum value was 136. We just concluded that every value in here was shifted 95 units downward. So that means in order to find the maximum value in the new number pattern, we only need to say 136 minus 95. Then 136 minus 95, that's equals to 41. And just like that, you have your solution for only a mark. So the new maximum value for this pattern would be 41. So here it was 136. Then when we shift it downward 95 units, it will be 41. Then that's all you were expected to do. Okay. Now we have 2.2. It says consider the sequence negative 11, 2 sine 3x, and then 15. It says determine the value of x in the interval for which the sequence will be arithmetic. Now, if this sequence has to be arithmetic, we know that this is what will happen. We have to calculate the common difference by saying t2 minus t1. That would be 2 sine 3x minus negative 11, so that's plus 11. Then this would be 15 minus 2 sine 3x. But then one thing that we know about an arithmetic sequence is that it has a common difference. So we can just go ahead and equate the two, right? Then let's calculate here. If we transpose this, this would be 2 sine 3x plus 2 sine 3x. Let's take the 11 over to that side. That's 15 minus 11. Then this will give us all these are like terms, so it will be 4 sine 3x. Then 15 minus 11, that's 4. Divide both sides by 4, that's sine 3x. So this speaks to the importance of having to just approach the question. If you just look at this question and you saw this 2 sine 3x, you'd conclude that this is a very difficult question. But then when you get to solve it, then you see that there is nothing there. Now to calculate here, we know that using our rules for the trigonometry, so we need to take over that sign and then say that this would be 3x. Then if we punch all that in our calculator, that's 90. Now at this point, we need to divide both sides by this 3. So our x is equals to 30 degrees. And just like that, you have found your solution, right? So that's all you needed to do for this question here. Nothing complicated. Okay, now let's look at this one. We are given the quadratic sequence 3, 2, 1, 290, 261, and 234. Now they say write down the value of the next two terms. So we have 321, 290, 261, and then 234. Right. Now we know first difference 290 minus 321. That's a negative 31. Then 261 minus 290. that's negative 29. And then if we say 234 minus 261, that's negative 27. Right. Now at this point, we can tell that there is a common second difference of 2. Right. So 2, positive 2. Now, in order to find the next two terms, we know that the second difference is consistent. So that's negative 27 plus 2, negative 25. So we need to say 234 minus 25. That's 209. Then again here, 2, consistent second difference. Negative 25 plus 2, that's negative 23. Now 209 minus 23, that's 186. So just like that, you have found the next two terms. So your next two terms are 209 and 186. Now 2.1.2 says determine the general term of the sequence in the form Tn is equal to an squared plus bn plus c. So in the quadratic format. So what we're going to do here, equate the second difference to 2a, equate the first difference to 3a plus b, and then equate the value of the quadratic sequence to a plus b plus c. And then we just go ahead and select the first branch. So that's 2a is equals to 2. Divide both sides by 2. Our a is equals to 1. And then if we want to find the value of b, that's 3 times 1 plus b is equals to negative 31. So our b is negative 31 minus 3. So b is equals to negative 34. Right. Then to find the value for c, we have our a is 1. And then our b is negative 34. So that's 1 minus 34. 1 minus 34 plus c is equals to 321. So c is equals to 321 minus 1 plus 34. So I just took all this, transpose it over to this side. So 321 minus 1 plus 34, that's 354. So that means our Tn in the form of an squared plus bn plus c, that's equals to a is 1, so that's n squared. Our b is negative 34, so that's negative 34n. And then our c, it's 354, right? So we have 354. Then just like that, that's how we would have calculated that. Okay, now let's proceed. 2.1.3 says which terms of the sequence will have a value of 74? Which term or terms? So that means it can be one term or two terms, right? So let's calculate. Remember, for this one, we need our Tn. So the Tn was n squared minus 34n plus 354, right? So we can just go ahead and substitute 74 here, because what are we looking for? We are looking for n, and we are given the value. So the value is Tn. Right, then it's equals to n squared minus 34n plus 354. Let's take this 74 over to this side. So that's n squared minus 34n, and then 354 minus 74, that gives us 280. So positive 280 is equals to 0. Now let's factorize this. We know for that one, we can just go ahead and use the quadratic formula, right? So this is in quadratic format. So the quadratic formula is allowed there. So I'm getting my values as n is equals to 20. And then the other one, if I change the plus to a minus, I'm getting it as 14, n is equals to 14. So I'm just going to go ahead and write this like this, as if I factorized n minus 20. And then n minus 14 is equals to 0. So my n is equals to 20, or my n is equals to 14. So there are two values, which is why they said which term or terms, right? So there are two values whereby we produce 70. There are two terms meant to say whereby we produce a value of 74. So it's when n is equals to 20, or when n is equals to 14. Right. Now, let's proceed. Which term in the sequence has the least value? right? Again, why are they asking about the least value? Because looking at our Tn is equals to n squared minus 34n plus, let's look at the value of a here. Our value of a is positive. We know that if we have a greater than 0, then this is a concave graph which will produce a what? A minimum value. So which is why they're asking about the least value. Which term in the sequence will have the least value? So they don't want the least value. They want the term which produces the least value. So we just need to do this. N is equals to negative b over 2a. And then what is our b? Is negative 34. So substitute negative 34 here. And then 2. What is our a? It's 1, right? So let's have 34 divided by 2. That's equals to 17. So you just leave it at that. That's just 2 marks. They want which term? So they're looking for n. So n is equals to 17. Note that this is not the least value. This is the position where the least value occurs. So if had they asked you to calculate the least value, then you would need to take the 17 and substitute it back to this equation here. Then you'd find your minimum value, right? Then let's proceed. Down here, we have the geometric sequence. So 2.2 says given the geometric sequence 5 over 8 plus 5 over 16 plus 5 over 32 plus a whole lot of values and then k, right? So we know that if we are given this is a series, and all these terms, if you add all these terms all the way up until whatever value, then you'd get k, which represents, the k here represents the sum of the terms, right? So it represents the sum of the terms. Hence, in 2.2.1, we are asked determine the value of k if the series has 21 terms. So that means the value of k is the sum of 21 terms, right? So we can say k is the sum of 21 terms. Now, in order to calculate the sum, we know, first of all, we need to find what is our a. Our a is 5 over 8. So that's the first term. Then what is our r? To calculate r, we say T2 divided by T1 or T3 divided by T2, right? So what is T2? That's 5 over 16 divided by 5 over 8. That's 1 over 2. Again, if you say 5 over 32 divided by 5 over 16, that's also 1 over 2. So that's your r value. Your r is equals to half, and then your a is 5 over 8. So you have everything that you need, right? So that means you can go ahead and say Sn is equals to a. Now note, you have two equations when it comes to this. You have that, and then where your r must not be equals to 1 because it would be undefined. And then another one that you have is Sna, Rn minus 1, and then r minus 1, where again r must not be equals to 1. It will be undefined. Now you need to choose which one do you need to use. Remember, we said this one, 1 minus r, you use it if your r is less than 1. And then this one, r minus 1, you use it when your r is greater than 1. Looking at our value of r, we can see that r 1 over 2 is 0.5, which is less than 1. So we need to use this one here. Okay, so I hope you understand the choice of formula. Now let's calculate. This would be Sn is equals to a 1 minus Rn, and then 1 minus r, where our r should not be equals to 1. The a value is 5 over 8. Then we have 1 minus r is 1 over 2. And then to the exponent of what? 21, because they said 21 terms. Then this is 1 minus 1 over 2. Then at this point, you don't want to complicate yourself. You just want to go ahead and punch it exactly in your calculator like that. So make sure you also include those brackets there. So that's 1.9999, a lot of nines, which can be approximately 2, right? So your k value is approximately 2. If you round it off. So let's look at 2.2.2. It says determine the largest value of n for which Tn will be greater than 5 over 8,192. So now let's check. This is saying where Tn will be greater than that. So that means this involves us having to find the general term of the geometric series first. So we have Tn is equals to a r to the exponent of n minus 1. Then this is Tn. Our a value is still 5 over 8. And then our r value, remember, we calculated it to be 1 over 2, right? And then to the exponent of n minus 1. But then remember, our Tn must be greater than 5 over 8192. So we have to take the value here, or our formula, and equate it to this inequality there, or express it to that inequality. Then we have that greater than 5 over 8192. Right. Now, at this point, note, you cannot multiply this. So this is usually the mistakes that a lot of learners make. Do not multiply this 2. This is just a coefficient. And this one here is a power. So we can see this is a base raised to an exponent. So all this is a power. So what you need to do with this one is get rid of the 5 over 8 by multiplying with its reciprocal. So we have 8 over 5. But what you do on the left-hand side, you also have to do on the right-hand side. Right, so this will cancel off this, and then we'll be left with 1 over 2 to the exponent of n minus 1, then greater than. So if this one cancels, we have 8 over 8192, right? Then we can further punch this in a calculator. If you punch that in your calculator, that will give you 1 over 1024, right? Now we have to write this one in terms of base 1 over 2 here. So if we are to write that one, this will give us 1 over 2 to the exponent of n minus 1. Then let's take 1024 and then say 1024 equals, and then shift fact. That should give you 2 to the exponent of 10. So that means we can write all this as 1 over 2 to the exponent of 10, right? Then, but then remember, when we are working with exponents, we should write our exponent in terms of prime factors, right? So let's go ahead and change this 1 over 2 using the law that says if we have a to the exponent of negative n, this can be written as 1 over a to the exponent of n. So we're just going to go ahead and change this one back to that, right? So we're going to express this 1 over 2 as 2 to the exponent of negative 1. So this would be 2 to the exponent of negative 1. And then outside here, we still have the n minus 1. Then also this one, this would be 2 to the exponent of negative 1. Then we have the 10 outside there. Now, let's continue with the question. So now if we have the base 2 there, what we are supposed to do now is to say 2 to the exponent of negative n. And then this is negative 1 times n, that's negative n. Negative 1 times negative 1, that's positive 1. Then greater than, this is negative 1 multiplied by 10. So that's 10 to the exponent of negative 2 to the exponent of negative 10. Right. So note that I've expressed this in the form of base 2. So remember, when we are working with exponents, we want to express them, we want to express our exponents in terms of prime factors. So that's why we did that. So this one, the bases are the same. That means we can drop the exponents. That's negative n plus 1, and then greater than negative 10, right? So if we take this one, transpose it over to the other side, so that's negative n greater than, when we take this one, transpose it over, that will give us negative 11. So that will be negative 10 minus 1. So it's negative 11. But then remember, if we are to divide this by negative 1, what dividing by negative does is that it changes our sign here. So the greater than sign will now be a less than sign. So this changes the direction of the sign. So our n is less than 11. Right. So what is the largest value of n? What is the largest value of n that is less than 11? Remember, we are trying to get the largest value of n for which Tn will be greater than 5 over 8,192. So in order to find the largest value, this is telling us that the integer here has to be less than 11. right? So why am I saying the integer? Because n, remember, must always be an element of natural numbers, right? It should be, in this case, a positive integer, right? Which that positive integer must be a natural number, which means 0 is excluded, right? So, okay, now what is the largest value that is less than 11? The largest value that is less than 11 is 10. So that means the largest value for which Tn will be greater than 5 over 8,192 is when n is equals to 10. So we can go ahead and try to prove it. If we say T10, this is 5 over 8, and then we say 1 over 2, then substitute our 10 here. Let's see if the value that we get here will be greater than that value that we are given here, the 5 over 8,192. So if we punch that, that's 5 over 8, and then multiplied by 1 over 2, then we have to the exponent of 10 minus 1. So the value that we are getting from that one is 5 over 4096, right? So which is greater than this value here. Remember, if you want to see that a value is greater here, we can see that we have the same numerator, but then if we have a smaller number on the denominator versus another number with a bigger denominator, the one with the smaller denominator is always the greatest value, right? So for example, if we can put it like this, if we have 2 over 9 versus 2 over 5. The biggest value here is not 2 over 9. It is actually 2 over 5 because it has a smaller denominator here. So a smaller denominator makes this to be a bigger number, right? So 5 over 4096 is greater than 5 over 8192, right? So our largest value is definitely n is equals to 10. So that's how you could have solved that question, guys. So, yeah, be careful of this question. Keep on practicing this type of questions because this is one of the questions that might pose to be a challenge when it comes to your exam papers, right? Now, the last question that we have here for the day says we are given quadratic sequence 20, 12, 10, and 14. Now they say determine an expression for the n term of the pattern. So we already expect that to be the first question. So that's -8. And then here we have -2. And then this would be, so let's check, this 14 minus will be 4, right? So -2 minus that, that's +6, and then also here that's +6. Now to find our a value, let's equate this to 2a, equate this to 3a plus b, then equate this to a plus b plus c, right? So to calculate the value for a, that's 2a is equals to 6, divide both sides by 2. My a value is 3. To calculate the value for b, that's 3 times 3, then plus b is equals to -8. So b is equals to -8 minus 9. 3 times 3 is 9, remember? If we transpose it over, that's -9. So -8 minus 9, that's -17. To find the value for c, that's 3 minus 17 plus c is equals to 20. So c is equals to 20 minus 3 plus 17. So 20 minus 3 plus 17, that's 34, right? So our Tn would have to be 3n squared minus 17n plus 34. And that's how you could have got that one. Now let's move to 2.1.2. It says the first differences form an arithmetic sequence. The first differences form an arithmetic sequence. So finally, they told us what I've been trying to tell you all along, all throughout the video. The first differences always form an arithmetic sequence. Determine between which successive terms in the quadratic sequence the first difference will be. So let's do that one. We have 20, 12, and then 10, 14. Remember, our first difference was -8 here, then negative 2 here, and then positive 4. Then we had 6, 6. Now, our eyes are fixated here. The first difference and its common difference. Now, to produce the Tn for the first differences, we'll say Tn is equals to A plus n minus 1 D. Remember the Tn, the first differences must be 148. We can substitute 148 here. What is our A? It's negative 8. Then plus n minus 1, and then D is 6. So remember, we are looking for the term. So we can take this 8 here, transpose it over. So that's 148 plus 8 is equals to 6 times n, that's 6n. 6 times negative 1, that's negative 6. Then if we say 148 plus 8, that's 156. So we have 156 plus the 6, if we transpose it over to this side, is equals to 6n. Now this is 156 plus 6, that's 162, is equals to 6n. Divide both sides by 6. If we divide both sides by 6, then our n value is equals to 27. Now, if 148 is found in the 27th position of the first differences, we already know from doing a whole lot of questions like this that means it will be located between the 27th and the 28th term of the quadratic sequence, right? So if 148 is found in the 27th position of the arithmetic sequence, that means in respect to the quadratic sequence, it's in between the 27th and the 28th term, right? As we can see here, the first term of the first differences is in between the first and the second term of the quadratic. The second term of the first differences is in between the second and the third term, right? Now, 2.1.3 says determine the smallest value of n for which Sn is greater than 10,140 in the arithmetic sequence, right? So Sn, they're talking about the sum. So that means we need to say Sn is equals to n over 2, and then that's 2a plus n minus 1 d. But then remember, this needs to be greater than 10,140. So we can just go, we are looking for n, remember? So that's 5 marks. So n over 2, and then our a value, remember our a value, when we said 12 minus 20, we got negative 8. So that's our a in the arithmetic sequence. So negative 8 plus n minus 1, and then d, remember we had 6 here. Greater than 10,140, right? So in order to solve this, guys, quick way to do it is just to get rid of this 2 first by multiplying by 2 here. So you are just multiplying by the reciprocal. Remember, this is 1 over 2. The reciprocal of 1 over 2 is 2 over 1. So multiply both sides by this 2. So we are left with n here. 2 times negative 8, that's negative 16. 6 times n, that's 6n, and then minus 6. And then greater than, if we multiply this by 2, 10,140 multiplied by 2, that's 20,208, right? Then let's calculate here. We have inside the bracket 6n, negative 16 minus 6, that's minus 22, and then greater than 20,280. Then let's multiply inside with this n, that's 6n squared, minus 22n. Then let's bring over this number here, minus 20,280, and then greater than 0, right? So looking at these numbers, we can tell that they can all be divisible by 2. If we divide everything throughout here by 2, then we have 3n squared minus 11n, then minus 10,140. So it goes back there, right? Okay, now at this point, we can use our quadratic formula to factorize because this is a very big number. So let's just go ahead and use our quadratic formula. So yeah, all over 2a. So I'll just punch it in my calculator. So I'm getting my values as n is equals to 60. And then I'm getting the other value. I'm getting the other value as n is equals to negative 169 over 3. So to just write them as if I factorized, this is what I will do. This would be bracket n minus 60, and then in bracket 3n plus 169 greater than 0. Then my critical values are negative 169 over 3, and then 60 as well. But then they're looking for the smallest value of n for which Sn will be greater than that. Now, we know that this one will not be applicable because our n must always be an element of natural numbers. So this is not a natural number. The only value that we can consider is n is equal to 60. But then we are not looking for a value whereby our arithmetic sequence will be equals to 10,140. We are looking for whereby our Sn will be greater than that. So in order for it to be greater, that means we have to consider an integer that is greater than 60, right? Because as we can see here, this would be written as n greater than 60. What is that first integer whereby we have n greater than 60? So we know the first integer that is greater than 60 is 61. So that means our n is equals to 61. So note with this one, because they said determine the smallest value of n for which Sn will be greater than, right? So because it's Sn needs to be greater than that, that means we have to consider a value that comes after this critical value. So the value that comes after that critical value is obviously 61. Right. So that will be the smallest value for which our pattern here will be found to be greater than this number here. So remember, 62, it can also produce a number that is greater than that, but then we are looking for that one smallest value, for that one integer that will produce a number that is greater than that. And it has to be the first integer that comes after the critical value. So just like that, you have answered your question. Now, let's go to 2.2. The sum of r plus b is equal to 10a, running from r is equal to 1 to 5. Then they say determine b in terms of a, right? So the first thing that you need to do with this one is to find how many terms are here. So to find the number of terms, you just say n is equal to upper value minus lower value plus 1. Your upper value is 5. Your lower value is 1, then plus 1, then your number of terms is 5. So that means you can make a pattern out of this number of terms here by simply saying, if this, remember, this means that you need to have 5 terms. Starting from r being equal to 1, then you substitute r2, r3, r4, and then all the way up until 5. So we can form a pattern out of that. So let's see, we will have 1 plus b as our first term, followed by 2 plus b, followed by 3 plus b, followed by 4 plus b. So you can see where I have r, I'm just substituting the numbers. Then I have 5 plus b, right? Then all this must be equal to what? All this must be equal to 10a. That's what that's saying here. Now, if we can add all this, that's 1 plus 2 plus 3 plus 4 plus 5. And that gives me 15, right? And then if I add all this b, that will give me 5b. Now at this point, I have 15 plus 5b is equals to 10a, right? Now all the numbers here are divisible by 5. So let's go ahead and divide everything throughout by 5. So 15 divided by 5, that's 3. And then plus b is equals to 2a. Remember, I must express b in terms of a. So I can make b the subject of the formula. Then this is equal to 2a minus 3. Then, just like that, I have my solution. So b is equal to 2a minus 3 in terms of a. So that's all you needed to do for that question. So it's just a matter of understanding what is the meaning of this. This means the sum of r plus b is, if you are running your r values from +1 to +5, right? Then all this should give you the sum of the 5 terms to be equals to 10a. So now that you have expressed all these 5 terms here, you can equate it to 10a because this is the sum of this pattern here, or this series. Then just like that, you have found your value for b in terms of a, right? So that's it, guys, with this question. So make sure that you practice. I've tried to pick out one of those challenging questions from all this, and then gradually I went with this question. So you can see, if you've been watching the video, we went from an easier question to fairly difficult questions. So that's what you do when you are practicing, guys. Always make sure to build that momentum first with the easier question, and then you come after with the more challenging questions. So don't just go there and start with the difficult questions, because that will just kill your spirit and then will destroy that momentum. So you want to start with something that is much easier to understand. Then you gradually move to the questions that are difficult, right? And then just like that, you'll be building your momentum. So please press that thumbs up button if you have enjoyed this lesson. And then if you are watching and you haven't subscribed, please do subscribe, and then share the link with your friends and classmates so that they may also find assistance. Remember, don't be selfish. We are winning as a team.